Hello students. Today in this session we will be discussing about all the properties of correlation coefficient. Now in our previous session what we had discussed different methods of different methods used for calculating correlation coefficient. Now we also discussed the four important properties of correlation coefficient, that is, the coefficient of correlation lies between -1 and +1. That means the value of correlation coefficient lies between -1 to +1. The coefficient of correlation is independent of change of scale and origin of the variable x and y. Third, the coefficient of correlation is the geometric mean of two regression coefficients. And the fourth one, the degree of relationship between the two variables is symmetric. That means whether you take the value of rxy or you calculate the coefficient correlation of ryx, the value will be same. So this one, the fourth one we have already discussed. The third one we will be discussing when we start regression analysis. So in today's session, we will be focusing on the proof of first two. So we will prove the coefficient, how the value of coefficient of correlation lies between -1 and +1, and how it is independent of change of scale and origin. So let's prove these two properties. So for that, let me open the Word file. So first one, we are trying to prove that the coefficient of correlation lies between -1 and +1. So this we will prove now. So to prove, let's take a quantity. So to prove this, I'll take one quantity. So what quantity we are taking? Small x by standard deviation of x plus minus y by standard deviation of y, where small x is equal to x minus x bar and small y is equal to y minus y bar. So where small x is equal to x minus x bar and small y is equal to y minus y bar. Okay. Now if we will take the square of these two values. Okay, square of these two values which we have taken. So that will come. So any square term. So let me take the square of this. So what we are doing now, whatever value we have taken, that is x by standard deviation of x and y by standard deviation of y, is greater than 0, because any square term definitely it will be greater than 0. Okay. So this x, small x by standard deviation of x plus minus y by standard deviation of y square. Okay. So now if we take this over n observation, so if we take this taking over n observations, what we can write? We can write summation of x standard deviation of x plus minus y standard deviation of y whole square greater than equal to 0. So if we take square, which you can write so y, sorry, small y, this one, this is standard deviation of x y standard deviation of y x. Then So over n observation we can write like this. Now if we'll open the bracket, okay, so how do we write? We'll write, because this can be written in the form of a plus b's whole square. So what we can write here, if I'll expand it, then let me do that. So now I'm expanding this one. Okay. So basically a square plus b square plus minus 2ab here as per the formula. So what we will write here, a square means x by standard deviation of x whole square, which can be written as s square standard deviation x whole square. Now plus b square, that is y by standard deviation y whole square, plus minus 2ab. Now 2ab means 2abx standard deviation x into y standard deviation of y. So let me write this one. This will be x square now, and this one will be standard deviation of x square, and this is y square and standard deviation of y's. Plus minus 2ab. So 2ab, a for a, x by standard deviation x into y by standard deviation of y. So what we are writing here, x square x square y square. Now standard deviation of x standard deviation of x square, then standard deviation of y square, so 2ab, which can be written 2xy into standard deviation divided by standard deviation x by standard deviation of y. So this will be definitely greater than 0. I've just expanded the equation, so it will also be greater than equal to 0. Now multiply the summation in each item. So what will be the, if we multiply, what we will get? So what we will get here? So by multiplying summation in each item, what we will get now? Let me write that once again. So we'll now, in the next step, what we'll do, we'll multiply this summation with a. This is a means x square plus x square by standard deviation x square, then y square by standard deviation of y whole square, sorry, standard deviation of y square, then here. So each item now will multiply. Now for that, so what I have to do, I have to rewrite this equation once again. So summation x square, this is, we know, some standard deviation of x square. So we are multiplying summation in each item. Then summation y square, then here standard deviation y whole square, next is, so we'll multiply here, so 2 summation xy, which we are multiplying this over n observation, we are multiplying summation xy, then standard deviation of x, standard deviation of y. Okay, so this definitely will be greater than equal to 0, greater than equal to 0. Now, so what we'll do, so summation x square, standard deviation of x square, summation x square, standard deviation of x square, summation y square, standard deviation of y square, okay, and 2xy, standard deviation of x, standard deviation of y. So we'll now replace these values. Now here we know that the value of standard deviation of x square, okay, that means what is the formula of standard deviation of x? The first formula, summation small x square by n's whole root over. So if standard deviation of x square, that means this root over will be removed. So we can write that now. Let me write first. So we know that standard deviation of x square standard deviation of x square can be rewritten as summation of x square by n summation of x square by n. Okay, or if we cross, if summation of x square by n means, now in this value, okay, instead of standard deviation of x square, we'll write now summation of x square by n, or you can say here, now for this value, now we'll write what we'll write, okay. So now which you can write, so summation x square will be cancelled. So we can write, instead of standard deviation of x square, this summation x square by standard deviation of x square can be written as n. Similarly, summation y square by standard deviation of y square can also be written as n. So similarly, can also be written as n. Okay. Now what I said, we have to replace all the values. Now this value also can be rewritten. So let me rewrite. So please recall the uh, correlation coefficients first formula. So what we will rewrite, okay, we can rewrite as 2nr. Why? Because as we know that r is equal to the first formula of correlation coefficient, summation xy n standard deviation of x, standard deviation of y. We had discussed this one, n standard deviation of x, standard deviation of y. Standard deviation of y, standard deviation of x. Okay, so we can write this one as 2nr. Okay, now you just replace these values now. Okay, so the first value, okay, so what we can write now, n plus n plus n, then plus minus 2nr, plus minus 2nr, which is greater than equal to 0. Now this you can write as two n plus minus 2nr, so which you can write 2n plus minus 2nr greater than equal to 0. Now here 2n is common, so what remains? 1 plus minus r is greater than equal to 0. Now divide this 2n in both the side now. Next step, divide 2n both the side. What will remain? 2n 1 plus minus r now 2n and 0 to n. Now in here 2n will be cancelled, 0 by 2n will be 0. So next what remains? Next remain 1 plus minus r is equal to greater than equal to 0. So we can write now 1 plus minus r is greater than equal to 0. Now here if we can write now, next we can write 1 plus r greater than equal to 0. So what we can write? 1 plus r greater than equal to 0, which will come as, if we take r value, r, you take 1 in the right hand side, so r will be greater than equal to minus 1. So next which you can write r greater than equal to minus 1, and then next one is 1 minus, next one is 1 minus r greater than equal to 0. Next you can write 1 minus r greater than equal to 0. So which you can write in the next step, which you can write r less than equal to plus 1. Okay, because r you took to that side, so r less than 1 to plus 1. So this proves that the value of r or correlation coefficient lies between minus 1 to plus 1. Okay, and so while calculating the correlation coefficient, if the value exceeds plus 1, then exceeds plus 1 or exceeds minus 1, then that means it should be, sorry, if it exceeds plus 1, that means there must be some miscalculation from your side. Okay, it will be greater than equal to minus 1. So the value ranges between minus 1 to plus 1. So this is the first proof, and the next one will prove that the coefficient of correlation, in the next proof will prove that the coefficient of correlation is independent of change of scale and origin of the variable x and y. So now we'll prove this one. So the next property is the coefficient of correlation is independent of change of scale and origin of the variable x and y. So first you need to understand what is change of origin and what is change of scale. Now change of origin is anything you either subtract or add to the constant, and change of scale is anything you divide or multiply. So basically what we are saying, if we are dividing or multiplying anything from the variable x and y, and you are subtracting or adding, the value of correlation coefficient is not going to change. So for that, let me prove this one. We know that we know the value of correlation coefficient can be written as the value of correlation coefficient you can write as rxy xy So we know that the correlation coefficient formula is equal to summation small xy divided by summation small x square into summation small y squares whole root over. So that formula I am writing here. So summation small xy, I can write it as summation x minus x bar y minus y bar. So instead of small x small y, what I am writing? I am writing x minus x bar and y minus y bar. Okay. and here summation small x squares summation small y squares whole root over I'll write as x minus x bars whole square and y minus y bars whole square. So only thing is I'm rearranging this one. Okay. At xy. Okay. So here we know that x bar and y bar refer to actual mean of x and y series. Now what we have to do, we have to for the change of origin and change of scale from the value x and y, we have to add or subtract something, and we have to either we have to divide or multiply some constant. So from we have now what we have to do, we have to now suppose this is two series, we have variable x and y. Now from the variable from the variable x and y, we have to subtract we have to subtract we have to subtract a and b, and then we have to also divide two more constant from the series variable x and y, that is x and h and k. Okay. So now let me rewrite the series. So we had variable x and y. So for x I am writing it as u. So u is equal to, we are writing u is equal to x minus a by h, here x minus a, and for y what we will write, v, for y we are writing v is equal to y minus b by k, y minus b by k. Okay. So now just cross multiply these two equations. Okay. So what we will get, now cross multiply, we will get h, first equation we are cross multiplying, hu is equal to x minus a. which can be written as HU plus A, or X is equal to HU plus A. So next you can write it, X is equal to HU plus A. Similarly, when we cross multiply this one, what we'll get? We'll get KV is equal to KV is equal to Y minus B, and rearrange this one, you will get Y is equal to KV plus B. Y is equal to KV plus B. So next, summing both sides by, so taking over n, summing both the sides, what we'll get? So here we are doing first one x, so summation x, so summing both the sides, you will get, for the first one, summation of x, so we are doing for the x series, is equal to, since it is a constant a, we are writing na, then h plus h summation of u. Okay, so divide n now both the sides. Now divide n, what will get? Summation x by n is equal to, so let me first write, then we'll put all the figures here. So now we will divide n, so summation of x by n, now na, so h summation of u by n. Okay, so summation of x by n we know is x bar. Okay, na by n, n will get cancelled here, and summation u by n is nothing but h u bar, that is arithmetic mean of u. So we can rewrite this one equation once again. So summation x by n we can write as x bar summation x by n will be written as x bar, which is equal to x bar we can Na by n, which we can write as A, plus sum H, this one can be written as H U bar. Okay. Now x bar is equal to which we will write now x minus x bar is equal to A plus HU minus A plus HU bar. A plus H U bar. Okay. Now just open the bracket. What will get here? Open the bracket. We'll get A plus HU minus A minus H U bar, where now here A will get cancelled. Now what remains? HU minus H U bar. Now H you take common. What remain? U minus U bar. Okay. Similarly, for the series Y, we'll get similarly we'll get Y minus Y bar okay. Similarly, we'll get Y minus Y bar is equal to K V minus V minus V bar. Okay. Now rewrite our previous the first formula which we had written. So let me rewrite this formula. The Rxy is equal to summation x minus x bar into y minus y bar. Okay. So the first formula we have to rewrite here. Now what we will do, we will replace this value. Instead of x minus x bar, what value we have got? Instead of y minus y bar, we have to rewrite or we have to replace this value. Okay. Now put all those values here. So Rxy Rxy is equal to now instead of x minus x bar, what I'll write? I'll write hu minus u bar. So let me first give the bracket here. So I'll write hu minus v minus v bar. We have to write. So I have to write actually in capital letter v. Okay. And here what we'll write? Okay, I have not written summation here. Was okay. So here also in the denominator we'll replace the values. So in the denominator, what we have to write? Summation h u minus u bars square summation k summation k V minus V was square. Okay, so let me check whether I have written it correctly or not. Okay, I'm just doing it all the capital letter actually here. So U, okay, okay. Now we'll solve this one. Rxy is equal to, okay, Rxy is equal to, so summation summation h u minus u bar, then k v minus v bar. So in bracket you have to give summation. So what we will do now, so this is the square, the summation, what we will do now, now we will write here summation u minus u bar whole square and square v minus v was square. Okay, now here you just now multiply the hk. Okay, the constant you multiply, so rewrite this one. Now you can rewrite, so r x y is equal to, so what we'll do here, we'll just multiply this one, summation of summation hk is equal to u minus u bar so u minus u bar, and then comes v minus v bar. V minus v bar. Okay, so here now summation s square, summation k square, which will, if we take the root over, it will come as hk, so I am taking that hk outside. Okay, and then root over of summation hk of sk we have taken outside. Now we'll do it. So what we have to do, we have to write it u minus u bar square. Okay, u by u minus u bar square. Now summation of k minus, sorry, v minus v bars square whole square. Okay, so b minus b bar whole square. Now what will happen now? This hk will get, see, this hk will get cancelled. Okay, hk. So what will remain? Summation of u minus u bar into v minus v bar divided by summation of u minus u bar square summation of v minus v bar square. So instead our xy, now I can write it as r, we can write it as ryv. Okay, r r sorry ruv, we can write it as ruv, okay, which is equal to summation of u minus u bar v minus u minus u bar v minus v bar and summation of u minus u bars whole square and summation of v minus v bars whole square. Summation of, now we can write it as u minus u bars whole square and v minus v bars whole square. So u minus u bar whole square v minus v bars whole square. Now we started with the rxy and we end here ruv, which is same. You can see here. Okay. So for x we have written u, for y we have written v. Okay, and we got the same thing. So instead of xy we have written here ruv and this formula u minus u bars and v minus v bar summation of u minus u bars whole square and summation of v minus v bars whole squares whole root over. So because of this it is said that it is independent of change of origin and scale. After changing the origin and scale we are getting the same value. Let me tell once again what we discuss here. So what we are trying to prove here? We are trying to prove the coefficient of correlation was independent of change of origin and scale. That means we are trying to prove that if we are subtracting or dividing anything from the x and y series, the value will remain same. So instead of xy, what we have written, we are for change of origin, what we have to do, we have to we are here subtracting one constant, that is a, and for change of scale we have divided the value h. Okay, Similarly, for value for y series, what we have written, we have for changing the origin, we have subtracted b and we have divided k for change of scale, and we have given the name as u and v. Now here we have cross multiplied, hu becomes x minus a. Now x is equal to hu plus a. Similarly, we can get kv is equal to y minus b and y is equal to kv plus b. Now you will sum both the sides. Okay, sum both the sides. Now I am writing this as the equation 1. So this is equation 1, and this is equation 2. So what we have done here, okay, so both the sides in equation 1 we are summing it. So after summing it off, we are getting summation of x is equal to na plus h summation of u. Now divide n both the side. What we'll get? Summation x by n is equal to na by n plus h summation u by n. Summation x by n is nothing but x bar, and n will get cancelled here, a plus h u bar. So now x minus x bar, if we are writing, we can write x minus x bar left hand side. So a plus hu minus a plus hu bar. Now open the bracket, a plus hu minus a minus hu bar. So a will get cancelled, hu minus hu bar. Take h as common, u minus u bar. Similarly, for y minus y bar, we will get k v minus v bar. Now rewrite the equation, that is the formula of correlation coefficient Rxy is equal to summation x minus x bar into y minus y bar. Now in the denominator, instead of summation of small x square and summation of small y square, we are writing summation of x minus x bar square, summation of y minus y bar squares whole root over. Now we are replacing the values here. Instead of x minus x bar, we are writing hu minus u bar, k v minus v bar. And in the denominator also we have replaced the value. Now here in the numerator as it is, in the denominator what we have done, we have written summation of h square u minus u bar square into summation k square v minus v bar square. Okay. So here h square k square, it becomes hk. When you take the square root, it comes out, and summation of u minus u bar square and summation v minus v bar square. So hk will get cancelled. What remains? U minus u bar v minus v bar in the numerator, and in the denominator summation u minus u bars whole square summation of v minus v bars whole square whole root over, which is nothing but summation of small u v divided by summation of small u square into summation of v square whole root over, which is same as the formula which we started our discussion. Okay. So this proves that the coefficient of correlation is independent of change of scale and origin. So this is all about today's session, and so this is all about today's session. Thank you very much. In our next session, we'll discuss about regression. So we'll start with regression analysis. Thank you.